We started this calculus of variation, this topic in the last session. Already I told the weightage of the topic is a 7 mark, and throughout this topic we are going to learn only one particular type of the example, and that example is our aim is to find the curve y equal to fx, y is equal to fx, for which the integral value is a minimum, and that is a particular type of the problems we are discussing in calculus of variation. So one of the standard example, there are total 3 standard examples, or I will say not standard, general, there are 3 particular examples I will say, and the remaining are general examples. So one of that we already finished in the last session, and that was prove that the shortest distance between the 2 points in the plane is a straight line. Okay, this is one of the common particular example which is repeating in the exam again and again. So we done this example in the last session, and you already seen this is our solution. You can do either by the formula, either this formula by Euler's formula known as f minus y dash into dou f by dou y dash is equal to constant, or you can do the same example by this another formula also, that is main formula, dou f by dou y minus d dx of dou f by dou y dash is equal to 0. But I will generally suggest you to use this method, because this one is always a simple method whenever the integrand that f is free from x there. So better you should select f minus y dash into dou f by dou y dash is equal to constant whenever f is free from x. So that about the last example we done. Now come to the 2 more examples. There are 2 more standard examples or particular examples known as minimum surface of revolution and Barchictochrone problem. So these 3 examples, out of that, yes, shortest distance between the 2 points, this example is repeated many times. Then second is a minimum surface of revolution. Barchictochrone problem is very rarely asked, hardly once is asked in last 5-7 years. Okay, so we'll see it one by one. So this is the first question for today. You can see the question can be asked in 2 different ways. The first way, example 4 is written, find the curve passing through x1 y1 and x2 y2 for which when it is rotated about x-axis gives a minimum surface area. This one only given. Okay, we are given only this much. So you will observe the integral is missing in this question. So that time you have to remember the integral for that is this one. Okay, and let I tell you how that integral gives us a minimum surface area, or how it gives us a surface area first, and then we have to minimize it. Now, right now we are given 2 points. Say A is a point x1 y1 and B is a point as a x2 y2. We have these 2 points A and B, and there is one random curve is taken, and this curve we are rotating about an x-axis. We are rotating this curve about an x-axis. So actually we are getting the solid. When we rotate about x-axis, we get this much of solid only. Okay, so these outer parts are not there. So our aim is to find out the surface area of that solid generated when we rotate this arc AB about an x-axis, So this is the question. So for this, if we take some particular point, say P of xy, suppose P of xy is any point. At that point, suppose a ds is a small arc length. ds is a small arc length of that curve AB. Can anyone tell me what will be the surface area generated by, or first of all, when you rotate this ds, small arc length ds, about an x-axis, when you rotate this ds about an x-axis, what it will generate? Yes.
Circle.
It's not
exactly
CSH.
CSH, no?
It is a
Stump.
circular
That's
disc. Okay, it is like a circular disc.
the circular disc.
So
like the cylinder, the thing.
No, it will be a frustum.
The outer surface.
But height is very small then.
Very small height.
So I will say it is a disc. Okay. So this is the disc that you will get there. So for this circular disc now, what will be the surface area?
It's a curved surface area of cylinder, no, we can take.
Yes, curved surface area only.
Yeah, so then so
Yeah.
2 pi h, no, 2 pi h.
2
So
pi.
it's 2
Now
2
y
pi
is the
into,
radius because p of
yeah,
xy
so
is a
h is
point. So
ds,
this
yeah.
radius of that circle is y there.
Yeah, so y,
Okay,
so 2
so
pi
2
y.
pi y is the circumference of that circle into ds. So 2
Yes, sir.
pi y ds is the surface area of that circular disc or that cylinder, whatever you are thinking. So 2 pi y ds is the surface area of that disc, and we want complete surface area, entire surface area. So we have to just integrate it from x1 to x2 2 pi y ds. So our aim is to minimize this integral because the question is what is a curve for which when we rotate about an x-axis and we get a minimum surface area. Our aim is to get minimum surface area. Is the question clear first?
Yes, sir.
Our aim is to just minimize
Yes.
the integral x1 to x2 2 pi y ds. Okay, 2 pi y ds. This is ultimate our question. Even the question is asked in the first form, you should able to write this equation, and if the question is asked in the second form, then there is no problem because this integral is already provided to you. Okay, so that about the question first. So let me find out the curve y equal to fx for which this integral is a minimum, that integral have a minimum value. So let me see the solution. Okay, already the solution is written here, so I want to do that our own. So let me do it here only. No, the bigger space. Okay, so this is the integral that we have to minimize, that I is equal to, okay, no problem. I is equal to integral x1 to x2 2 pi y. What is the value of ds? Anyone? This is a small arc length. You should remember the value of a ds is a root of 1 plus y dash square dx. Is that? So this is just we proved in the previous example. Any doubt in writing the integral I? Am I audible?
Yes, sir.
Yes.
No, no, sir. I mean, yeah, audible. Yeah.
No,
Okay, okay.
no doubt in this.
No doubt.
Yeah.
Okay.
No doubt, no
So
doubt.
this is the integral. Now we already know this integral I will be minimum provided this integrand should satisfy the Euler equation. So out of this, actually 2 pi is a constant, no need to consider it. So we can take that 2 pi outside the integral and we keep only the variable part so that it's easy to differentiate. Actually, this constant doesn't play any role for minimization. So this is a y into root of 1 plus y dash square dx. So here integrand f is y into root of 1 plus y dash square, and we can say it is a free from x. It is a free from x. Therefore, this integrand should satisfy the Euler's equation, and that Euler's equation is y dash. Is it y dash?
Sir, F minus.
Yes,
Sir,
f
F
minus. Correct.
minus y dash dou f by dou y dash equal to 0.
F minus y dash into dou f
Dou f by
by
dou f
dou
y
y
dash.
dash should be a constant. Remember, some of the student writing 0 on the RHS and then they get wrong answer. So RHS is a constant in the second Euler's equation. First Euler's equation, dou f by dou y minus ddx of dou f by dou y dash is equal to 0 is there in the first Euler equation. Second Euler equation, RHS is a C there, constant. That's one. Now just we have to solve this equation for y equal to fx and we get the answer. So the first part, f is there, f is like y into root of 1 plus y dash square minus y dash. What is the dou f by dou y dash? The dou f by dou y dash.
So
Y
Y.
dash by under root
Okay,
1
one by
plus y
one.
dash.
Yes, sir. Y.
So y dash by under root 1 plus y dash, like 2 will get
Correct.
cancelled.
Okay. So that y will be as it is first. One that whatever y is there. Derivative of root of 1 plus y dash square with respect to y dash is 1 upon 2 root 1 plus y dash square into derivative of 1 plus y dash square is a 2y dash. So this way. And is equal to constant as it is. So obviously that 2 gets cancelled there. And we can move further cross multiplication. So this y into 1 plus y dash square minus y dash square y, so actually y is also there, into y, so this y divided by, or this divided by the square root I will take on the RHS. So I will take that square root on the RHS. So this will come c into root of 1 plus y dash square. I hope this is clear. So again, one thing happens here, this y dash square minus y dash square gets cancelled, and we're left with y is equal to c into root of 1 plus y dash square. Remember, our aim is to find y equal to fx. So we have to remove that y dash and we have to find it y as a function of x. So we can square both sides so that we can find the equation for y dash. So y square by c square is equal to 1 plus y dash square. Now I can write this as a y dash square as 1, sorry, y square minus y square by c square minus 1. So this one is taken on that side. So it will come y square minus c square upon c square there. Y square minus c square upon c square. Any doubt up to here, anyone?
No, sir.
Excuse me, sir.
Yes.
Sir, can you please explain the first equation?
This equation,
I is equals to yes, sir.
this is already given. 2 pi y and ds value is written there.
Okay, sir.
Okay. So this arc length value is written. ds is the root of 1 plus y dash square into dx. Okay. So the derivation, if you want, yes, it is already explained because this is the formula for the surface area of revolution. When you revolve some curve around an x-axis and you want surface area, the formula is given by this one. This is integral x1 to x2 2 pi y ds. That is a formula for surface area. And out of that, ds is arc length. So this arc length, ds small arc length, is given by root of 1 plus y dash square into dx. So indirectly, we have to minimize this integral so that f should satisfy this Euler's equation. So we are solving that Euler's equation here. So I will erase this side then, because we will observe this equation. This equation is simplified as y dash square is equal to y square minus c square divided by c square. So y dash is or y dash become root of y square minus c square divided by c. Yes, anyone? How to integrate now? How to integrate? Y dash is root of y square minus c square divided by c.
We have to put the formula under root x square minus a square.
Actually, this is not like a previous questions. Generally, we get y dash as a function of x, and when we get y dash as a function of x, just to integrate both sides. But here, y dash we get in terms of y only. This y dash we are getting in terms of y.
So y dash is dy
So we
by
should
dx.
write in
So we have to
variable
take dx there.
separable form. So this is a dy by dx. So I can write it as a dy upon root of y square minus c square, and this c I will write it in the numerator here, and this is equal to dx. Is it clear, or any doubt to write this step? Y dash is a dy by dx, and it is just written in variable separable form so that we can integrate LHS with y and RHS with x. Now hardly 2 steps left there. We get the curve for which this integral is a minimum. Any doubt?
No, sir.
No. So what is the integration of LHS now? What is the integration of 1 upon root of y square minus c square? 116. No. Yes, anyone? You can raise your hand.
Sir, 1 upon 2c.
Yes, 115. Yeah.
1 upon 2c log of
Huh.
y minus c upon y plus c.
I think it's not correct.
Uh,
This
so
integral is
will it
coming in
be
term
y
of
plus c upon y
logarithmic,
minus
na?
c?
Log of y plus root of y square minus c square something.
Oh, yes.
Okay. So the integral
Yes, sir.
either
No.
yes 179.
Yes, sir. I am telling that formula only.
Okay, that formula only, correct. So the formula for integration of 1 upon root of y square minus c square is a log of y plus root of y square minus c square. But remember, there is equivalent formula for inverse hyperbolic function. Inverse hyperbolic function. So whatever you are saying right now, that is a log of, I will write it here, log of y plus root of y square minus c square. So whatever this value is there, this value is known as cos h inverse
Cos
y.
H inverse. Yes,
Cos
sir.
h inverse y by c actually, if c is there. So you can check this formula, but I will write this integration. Right now you have to remember one new formula here, or you can add one more formula in your prerequisite list, and that formula is integrating both side. Integrating both side, the integration of left hand side is simply cos h inverse. This h is not constant, cos hyperbolic function is there, so that is not part of your syllabus, so we will not go in the detail. Right now, just remember this cos h inverse of y by c is the integral. Cos h inverse, just like you know sine inverse of x upon a. How you remember root of a square minus x square dx upon root of a square minus x square is sine inverse of x upon a. In the same way, here is one formula, integral of whatever this left hand side is there, the c is also required there. Then it is cos h inverse of y by c. No, actually c is outside. C will remain outside there. So c into cos h inverse y by c is equal to integral of dx is x plus constant of integration is a. I'm taking constant of integration. If you're not happy with a, you can take c1. Okay, so we'll get this c. If you take on the left hand side, it is coming x plus a upon c, and we get the final answer is written as y is equal to c times cos hyperbolic x plus a upon c. X plus a upon c. That's the final answer. Actually, as this is a standard example or particular example, generally the answer is expected in this form. This is the expected answer. If you write the answer in a logarithmic form, then also it is correct. But by probably examiner can deduct half or 1 mark because you are not writing the answer in that standard form there. So it's better you should remember new formula. The formula for that integration is this one, and we got the answer. And this is one standard curve, and that name of this curve is known as a catenary. The catenary is this curve. What is this catenary curve? Generally, cos hyperbolic curve takes the shape of the shape of catenary, and that catenary is nothing but when you hang the string or chain between two equal distance height point. Suppose from the ground at two equal distance, there are 2 points, and you are hanging the chain or the string there. Whatever the shape taken by that string or the chain because of the gravity, that shape is known as a catenary. That is a catenary. So that curve is there for which the surface area is a minimum. Okay, it's not like the curve like a straight line. So when you rotate the straight line and about an x-axis, it gives us a cylinder. Okay, it gives us a cylinder. You can generate a you can like rotate a semicircle also passing through that point, but that also not gives us a minimum surface area. The curve is like a catenary here, something like this, and for that curve you will get a minimum surface area. That minimum surface area. Is there any doubt now?
No, sir.
No. Okay, good. So already I told there are three standard examples. Two of them that we finished. First is minimum length between the 2 points. It is a straight line. Minimum surface area for the revolution about an x-axis is the catenary. is the catenary. Catenary is the answer. So I will erase this because this is already a solved example. I given each and every step in a solution. You can observe here, whatever we done, exactly same things are there. This is actually the surface area formula that you have to remember. The surface area of any curve from the point x1 to x2 is given by this formula. This is the formula you should remember, where the integrand f should satisfy this Euler's equation. So f minus y dash into dou f by dou y dash cross multiplied simplified, we get this equation. It's written in variable separable form and integrating, we got the answer there. So main thing is only the formula, that c into cos h inverse of y by c. Okay, so solution is there in the PPT. So those who are interested, again you can go through that, even though if you are not written right now. So can we move to the next question then?
Yes, sir.
Now this is a third and the last standard or particular formula, sorry, particular example, which is known as a Barchictochrone problem. The problem states like this. The statement of the problem is like this. Suppose we have some point. Let I take the point as a, say, A. From the point A, and there is another point. There is another point in the plane. I will say the point B, not exactly below it. Only it is not exactly below it. Let I take some point as a B here. Point A and point B are there. We are interested. We are interested in. We are interested in getting the curve under which, for example, suppose I will take one of the curve as a straight line. I'm taking a straight line from A to B. Now we are going to keep one rolling object. We are going to keep one rolling object at the point A. So okay, suppose it's like okay, some rolling object is there, and what is the curve under the gravity, that rolling object will come from point A to the point B in a minimum time. So our aim is to find a curve for which that object start rolling from A to B and comes under a minimum time, and we want the equation of that curve. Is it a straight line? Is it a curve like a parabola? Okay, something I will take. Is it a curve like a parabola? Is it a curve like a semicircle? Okay, or arc of circle, not semicircle only. It is arc of circle from A to B. There are cubic curves also like this. So what should be the curve? Can anyone guess? Anyone knows this?
Sir, I
Yes,
think it should be a parabola.
it should be a parabola. Okay. Any other answer? Okay, just I got one answer only, parabola there.
Cubic.
Cubic equation. Okay, so you are thinking that yes, it have a very big slope, and because of that it may come from it comes from A to B there. Okay. So I'm not drawn exactly perfect curves there, but yeah, I'm given some sample curves. But right now, yes, we've not done any mathematical part. So just by observing the curves, we are guessing the answer. The answer is not any curve from this. Okay, whatever four curves I'm saying, like straight line, parabola, arc of a circle, or cubic curves. Okay, actually the new curve is there, and that curve is known as cycloid. Okay, cycloid is a parametric curve. Again, this is new curve for you, just like catenary. Catenary you see in the previous. So cycloid is a curve. If you make a slope of the surface like a cycloid curve, then your object will come faster or quickest from point A to the point B under the gravity. Okay, in the absence of friction, obviously. So that curve is a catenary. Already I uploaded. Just I will show you for just I will show you that. Just 1 minute only. I will show you that small clip of the video because this is one of the interesting problem. So if you see now, just a minute only. Okay, some answers I got that time on the chat. 146 I already told. Okay, now you may come to know that the class is of only maths. Shrikant sir is not going to take it today. This is the calculus of variation. PPT of the calculus of variation, you can find it here. So minimum surface area, the shortest path in the plane, Barchictochrone problem, all that things I kept there. So Barchictochrone problem is here. You can see this small video there. So whatever this third curve is there, this is the catenary shape. This is the shape of catenary. Okay, there is a parabola, there is a straight line. Okay, this is the first one. This is the catenary. There is a different slopes given according to the different curves, and it is observed that catenary is a curve there, and that about the shape of catenary like this. I think this is the catenary here. So right now, yes, by observation also you can get, this is the maximum slope is there, but later on there's a flat area, flat line is there, or there is a zero slope is there near to the zero. Because of that, it comes fast here, but after that it slow down. This is the curve where you have, I think, constant acceleration, or it is coming fast here there only. Okay, not only this, another small videos also I given here for this catenary. You can go through it later on when you have time. So that about the curve, we are going to prove it mathematically now. That the point under, so the point that we have, that is a catenary, for which the particle is coming down in a shortest time or the minimum time there. Okay, so let me start the proof here. Again, the equation is not given here. That equation of the integral is not given, which we have to minimize. Actually, we have to minimize the equation of a time here. So first thing, we can take one rough diagram. This diagram is like this. Suppose this one is our x-axis, this one is a y-axis, and at the beginning, let us assume our particle is at origin, that is 0, 0. So at 0, 0, and we have to go from point O to some point A. Remember that O and A will not be on the same line, y-axis there. So A is somewhere other than y-axis. So uh, we have to move from point A to the A, and we have to find the curve for which the particle is coming from O to A in a minimum time. Okay, minimum time. So we'll take one random curve here. Let us take one random curve, say this one, and on this curve, suppose at any instant, at any time t, p of xy is a position of a particle. So we'll start like this. Let p of xy let p of xy be the position of a particle at any instant t, at any time t. Then by the principle of that work and energy, so those who know the physics now, principle of that work and energy. So we should have kinetic energy is equal to potential energy at any instant, at any time t. This equation always holds. That is, kinetic energy should be equal to the potential energy. Okay. Now kinetic energy, suppose m is the mass and v is the velocity of that. So kinetic energy is given as 1 by 2 mv square, and as y is the distance covered by that particle in below x-axis there, I think the potential energy, if you know the formula is there, this 1 by 2 mv square is a kinetic energy, and the potential energy should be mgy. So these are formulas. Okay, you should know these formulas. If you don't know, yes, you remember it. So mm gets cancelled. We get v square is equal to 2gy. So this is actually not 9. This is actually g. The problem I will write like this. So this is a 2gy. So v becomes root of 2gy. What is v? V is a ds by dt, rate of change of displacement. So here the displacement is along the arc, so it is a ds by dt, and the ds is a small arc length again. So ds by dt is a root 2gy. Our aim is to minimize the time, so we get now the equation for time t. So we can write the dt is equal to ds upon root of 2gy. So that about the small time t. Now, but we want from origin to the point A. So total time taken is suppose capital T. So capital T will be the integral of this. Okay, so integral of this this equation. So we can say therefore the time t, just change the color. So time t is the integral 0 because this is the original position at time t equal to 0, and this is the extreme point that we have. So say that is a x1 y1. Suppose the coordinate of A are x1 y1. So 0 to x1, because we are converting everything in x now. So ds is, see, remember 1 upon root 2g. 1 upon root of 2g is a constant. This root 2g. ds is root of 1 plus y dash square. 1 plus y dash square upon that root y should be there, and that dx. So this is the integral that we have to minimize now. Our aim is to minimize the integral value and this one. So in this case, the f is nothing but this 1 upon root 2g is constant, so ignore it. So f that we have is 1 plus root of 1 plus y dash square upon root y. 1 plus is equal to root of 1 plus y dash square upon root y, and this f we have to minimize. This one is we have to minimize. So we say we have to minimize this, so it should satisfy the Euler's equation. It should satisfy Euler's equation. Again, this f is a free from x. F is a free from x. So where we should start? We should start with
F minus y dash dou y dou f by dou y dash equal to
should be a
constant.
constant. So in this equation, yes, we have to replace these values and we have to simplify and we have to integrate. So if anyone have doubt up to this step, because this is only the important remaining part, yes, it is just a mathematical calculation now. So if you have the doubt, yes, you can ask. It is a derivation. It is indirectly like a, because I already told this is one of the standard problem or particular problem, and because of that you have to prove like that only, like this only. Sorry.
Sir, fifth step.
Yes.
Fifth step, sir. I didn't
Fifth
understand
step.
fifth step.
1, 2, 3, 4, 5. This one.
Yes, sir.
It is a v is a ds by dt only. Velocity is the rate of change of displacement, na? And displacement is in this along arc length. So
Yes, yes, sir.
so it is a
Got
ds
it.
by dt.
Yes, sir.
Okay.
Sir, after T, how did you get F?
Here
Yes, sir.
f is the integral, na? Integral that integrand, because 1 upon root 2g is like a constant that is outside the integral, and this f should be the f should satisfy the Euler's equation for integral to be the minimum. So that value of t should be minimum. Clear?
Okay, sir. Thank you.
Now only the 2-3 things left. Just to have to solve this equation. F minus y dash into dou f by dou y dash is equal to constant for this f. So let I erase everything and I will write only these two things now. Okay. So thus we are at this step. We have f here. We have f which is a root of 1 plus y dash square upon root y, and for this f, this should satisfy the equation f minus y dash into dou f by dou y dash should be a constant. So value of f is there, that is the root of 1 plus y dash square divided by root y minus y dash. What is the value of dou f by dou y dash now?
So 1
Sir,
by root
2
y.
into y dash.
Okay, correct. So again, that same thing will happen, that root y is a constant as it is. This is a 2y dash divided by 2 times root of 1 plus y dash square. So that 2 gets cancelled as usual in near about every example, is equal to constant should be there, correct? So you'll observe there is a same, no, there is not same denominator. So to make a same denominator, yes, you can cross multiply. So if you cross multiply this, you will get 1 plus y dash square minus y dash square divided by root y into root of 1 plus y dash square is equal to c. And the same thing will happen, that y dash square gets cancelled. So I'm cross multiplying and the squaring. Cross multiply at the same time, let me square it. So 1 is equal to c square into y into 1 plus y dash square. I hope there is no doubt here. What I done, this denominator taken on the RHS and squared both sides. So we have to solve it for y dash now. So yes, obviously it comes like 1 by c square y sorry is equal to 1 plus y dash square. So y dash square is 1 upon c square y minus 1. So this comes as 1 minus c square y upon c square y. So we want y dash only. So y dash is equal to root of 1 minus c square y divided by c root y. Again, y dash we get in terms of y, so we should write in variable separable form. So y dash is the dy by dx. So this root y I will take on that side, root y or c root y divided by root of 1 minus c square y square is equal to dx. So this is the integral that we have to integrate now, or this is the equation that we have to integrate. Yes, any method now? First, if you have any doubt up to this step, yes, you can ask, and then the method of integration now. How to integrate? Remember, this example is not asked in last 5 to 7 years. Okay, so it's not so important example, but yes, it is part of the syllabus. Yes, someone is telling there 101.
Sir, what happened?
Any doubt?
No.
So that will be c square y, no sir?
C square
Y.
y, correct. My mistake. Very good. Yeah, correct. These are the silly mistakes sometimes happens, and then you'll not get the correct answers there.
Sir, I think we will
Sir,
have to
we can
solve
put
it by
1 minus
using
c
rules, right?
square y equal to t.
1 minus c square y equal to t. Okay, so that is one of the way. But as I already told, these are like a standard example. So there are some standard procedures or standard answer is there. So we should come to that. So what we should do it, the first thing, I will take c square common from the denominator. If you take c square common, there you get 1 by c square. Okay, if you take c square outside, that becomes c only, and this become 1 by c square. I will take 1 by c square. Let I say that 1 by c square is equal to a square. Okay, so what will happen, this c comes out, it gets cancelled. You left with root y dy upon root of a square minus y is equal to dx. What happened? This c square taken outside the square root, so 1 by c square we assume as a new constant as a square. Okay, this is a square, we assume that as new constant here, and we got this integral. And now this is one of the standard example, and if you know to integrate this, y is equal to a square sine square theta. If you put y is equal to a square sine square theta, you will get the value of x then. So you get y in terms of theta, you get x also in terms of theta. You'll observe what happens then. If you put y equal to a square sine square theta, the numerator become a sine theta. Numerator become, this is a sine theta. This is the value of root y. The value of a dy. Now if you see dy here, dy is a 2a square sine theta cos theta d theta. Is it clear? What I
Yes,
have
sir.
written, root y written here first, dy value is written here. This is dy. What is the value of denominator now? Root
A
of
cos theta.
this is a cos theta, is it correct? A cos theta, and RHS become only dx as it is there. Okay, so this a cos theta gets cancelled, and now only the last thing we have to integrate it. We have to integrate this, and we get the answers then. And the answer we get in a parametric form now, because x and y, where x and y we are getting in a parametric form. So let I write that, then you'll come to know. So you will get dx equal to, this dx is equal to, which
A
things we
square
left?
sine cube theta.
2a square sine square theta, 2a square sine square theta d theta. Is that? Our aim is to integrate this, but to integrate sine square theta, we can take what is a 2 sine square theta? Yes, is it
1 plus cos 2 theta.
1 minus cos 2 theta? Not 1
Uh,
plus or 1 minus.
B minus 1.
Is that 1 minus cos 2 theta? Na?
Yes, sir.
Yes,
1
sir.
minus 1
It's a
yes, sir,
minus.
yes,
minus
yes.
minus.
So
Yes, sir, minus.
integrating x equal to, now integral of dx is x, a square as it is, integration of 1 with respect to theta now is a theta, integration of cos 2 theta is minus sine 2 theta upon 2 plus
Plus c.
c there. Okay, so the c is coming 0 there. Some terms
Sir,
are,
C
I
is
think,
already there, na? So,
just check the constant, are they correct? 2 sine square theta is
Sir, we missed that c out there.
where
Sir, dx equal to c root y, no? So we just
dx
put
is
root
equal
y
to,
out there. C root y dy by
no,
under root 1
we
minus c square.
cancelled, na? We taken the c
Oh,
common
oh,
from
okay,
the
okay,
denominator, it got cancelled.
okay.
Okay. So
Won't it
you,
be theta plus 2 sine 2 theta by 2 because
pardon,
it is already 1 minus cos 2 theta,
1
right?
minus cos 2 theta?
Yeah, so it will become plus sine 2 theta, right?
No,
Because cos 2 theta.
integration is integral is minus as it is, na? We're not differentiating.
yes, sir, it's correct.
Okay, so you can keep this as the answers. The answer is coming in x in terms of theta, y in terms of theta, and that is the answer. It's not like y equal to fx you are getting. You are getting x and y in terms of theta, and that is known as a parametric form.
Excuse me, sir.
Yes?
Sir, can you please brief what to do in this type of questions? I mean,
Yes, yes. What I will do it, I will show you the solution directly. So this is already solved, and I have this, here is a solution. You will observe each and every step here. First thing, you have this equation. Kinetic energy should equal to
Do we have to
potential.
substitute the value of theta after that?
Yes, you got this answer. This is the final answer you should write. Plus c is not written in parametric form, so ignore that. It is not, plus is not written when you integrate there.
Yes, sir. You have to take a sine square theta. You have taken a square sine square theta.
Yes, yes. Because of that, some probably. So it depends what we are writing there. Depending on that, small change, equivalent answers are there. But this is one of the standard solution, and you should get the
Sir,
answer in terms of this form only. Yeah. So these are the steps that you have. Kinetic energy equal to potential energy, and then this is the Euler's equation that should satisfy by this app. When you simplify, you will come this step here, and to integrate this, y equal to a sine square theta, that you have to substitute, that you have to remember again, y equal to a sine square theta. You get a cycloid. Now cycloid is this parametric curve. So cycloid is a curve like this. I will show you.
sir, for the minimum value of t, we take f, right?
Pardon?
For the minimum value of t, we took f, right?
Yes, whatever the value of this integrand is there, that is our f. Only constants we taken out. It's not required because their differentiation is zero there. It doesn't affect there.
Okay, sir. Thank you.
Okay, cycloid is a curve like this. If you have suppose some base, and on this base some circle is there, and now if you fix one of the point of that circle, and now if you rotate this circle in this direction, if you drag this circle along this rotation, and if you keep some pen on this side, so by the rotation, and you may get the curve like this then. So so the curve you stretch like this, and this is the graph of the cycloid there. Actually, this is the branch you'll get like this. So you'll get like curves like that, and this is the cycloid curve. Okay, and on that curve, actually, when something rolls down from origin to this some any other point, it is the arc taken as a cycloid there. That arc is taken as a cycloid there. Okay, so that is a curve we have. So if you want more detail about this curve, catenary, cycloid, yes, you can Google, you will get more details about that curve. But I will tell you the example of this Barchictochrone problem. Yes, that's not asked in last 5-6 years. Not so important as it is part of syllabus. Just we completed. Other examples are like a common similar examples there. So you should just focus on 3 examples. They are something special or the different, like shortest path between the 2 points is a straight line, minimum surface area after revolution is by catenary, and minimum time for the particle come under the gravity, that is a cycloid. So these are the 3 standard examples. Others are a particular examples just.